Welcome to Intelligence Gateway. What are the different deployment models for robotic process automation? There are three primary deployment models for robotic process automation, RPA. On-premise. In an on-premise deployment model, the RPA software is installed on servers or machines within an organization's own data center. This model provides greater control and customization, but requires more resources and expertise to manage. Cloud-based. In a cloud-based deployment model, the RPA software is hosted in the cloud by a third-party provider. This model is typically more cost-effective and scalable, but may provide less control and customization. Hybrid. A hybrid deployment model combines on-premise and cloud-based deployment models, allowing organizations to take advantage of the benefits of both. For example, an organization may use on-premise RPA for sensitive or highly customized processes, while using cloud-based RPA for less complex or resource-intensive processes. Each deployment model has its own advantages and disadvantages, and organizations must carefully evaluate their needs and resources before selecting a deployment model. How can you determine which deployment model is best for your needs? When it comes to choosing the best deployment model for your needs, there are several factors to consider. Here are some key considerations. Security. One of the most important factors to consider when choosing a deployment model is security. If you're dealing with sensitive data, you'll want to make sure that your deployment model provides adequate security measures. Scalability. Depending on your needs, you may require a deployment model that can scale quickly and easily to accommodate growth. If you anticipate significant growth in the future, you'll want to choose a model that can easily handle that growth. Cost. Another important consideration is the cost of the deployment model. Some models may be more expensive than others, depending on factors like the size of your organization and the level of support you require. Control. Depending on your organization's needs, you may require a high level of control over your deployment model. Some models provide more control than others, so it's important to choose one that meets your specific requirements. Ultimately, the best deployment model for your needs will depend on your organization's specific requirements and goals. Consider each of these factors carefully before making a decision, and be sure to consult with experts in the field to ensure that you're making an informed choice. What are the different types of robots used in robotic process automation? There are typically three types of robots used in robotic process automation, RPA. Attended robots. These are robots that work alongside humans to complete tasks. They are typically triggered by a human action, such as clicking a button, and can provide assistance in completing repetitive or time-consuming tasks. Unattended robots. These are robots that work autonomously without human intervention. They are typically scheduled to run at specific times or triggered by certain events, such as the arrival of an email or the completion of a previous task. Each type of robot has its own strengths and weaknesses and is suited to different types of tasks. Attended robots are best for tasks that require human decision-making or interaction, while unattended robots are better suited for highly repetitive tasks that can be automated entirely. Hybrid robots offer the flexibility to switch between these two modes depending on the task at hand. How can you choose the right type of robot for your needs? To choose the right type of robot for your needs, you should consider the following factors. Task complexity. If the tasks to be automated require a lot of human decision-making or interaction, an attended robot may be the best choice. For highly repetitive tasks that can be automated entirely, an unattended robot may be more appropriate. Volume of work. If you have a large volume of work to automate, an unattended robot may be the best choice, as it can work autonomously and process a high volume of work. Cost. The cost of implementing a robot should also be considered. Unattended robots tend to be more expensive than attended robots, so if cost is a concern, an attended robot may be a better choice. Complexity of the system. If the system to be automated is complex, a hybrid robot may be the best choice. This type of robot can work alongside humans when needed and can also work autonomously when appropriate. By considering these factors, you can choose the right type of robot for your needs and ensure that you are getting the most value out of your investment in automation. What are the best practices for robot maintenance? Here are some best practices for robot maintenance. Regularly clean the robot to prevent dust and debris from interfering with its sensors and moving parts. Lubricate the robot's joints and bearings according to the manufacturer's instructions. Replace worn or damaged parts promptly to avoid more significant problems down the line. Regularly inspect the robot's electrical components and wiring for damage and wear and tear. Keep the robot's software and firmware up to date with the latest updates from the manufacturer. Train personnel on how to properly use and maintain the robot to minimize the risk of damage and downtime. Have a maintenance schedule in place to perform regular checks and maintenance tasks on the robot. What are the best practices for robot monitoring? Here are some best practices for robot monitoring. Monitor the robot's performance metrics, such as speed, accuracy, and uptime, to ensure it's functioning properly. Use sensors to track the robot's movement, location, and environmental conditions to identify any issues or anomalies. Implement a real-time monitoring system that can alert operators of any problems immediately. Collect and analyze data on the robot's usage and performance to identify trends and potential areas for improvement. Conduct regular risk assessments to ensure the robot is operating safely and not posing a threat to personnel or equipment. Develop contingency plans in case of a robot malfunction or unexpected behavior. Train personnel on how to monitor and interpret the robot's data and performance metrics. How can you manage multiple robots in a single environment? Here are some ways to manage multiple robots in a single environment. Use a centralized control system to manage all robots from a single interface. Establish communication protocols and standardize programming languages to facilitate coordination between robots. Assign specific tasks to each robot to avoid redundancy and optimize efficiency. Use sensors and cameras to monitor the environment and coordinate the robot's movements and actions. Implement a system of priority levels to manage conflicting demands or emergencies. Provide regular maintenance and updates to ensure all robots are functioning properly. Train personnel on how to operate and manage multiple robots, including troubleshooting and problem solving. How can you manage the data generated by automated processes? Here are some ways to manage the data generated by automated processes. Determine what data is critical to your operations and ensure that it's captured and stored appropriately. Use data analytics tools to extract insights and identify patterns in the data. Implement a data storage and retrieval system that is secure, scalable, and easy to use. Regularly back up data to prevent loss or corruption. Ensure compliance with data privacy and security regulations. Establish data governance policies and procedures to manage data quality, access, and usage. Train personnel on how to collect, manage, and analyze data, including how to interpret results and make informed decisions based on the data. How can you ensure data security in robotic process automation? Here are some ways to ensure data security in robotic process automation. Use secure communication protocols, such as HTTPS, to ensure that data is encrypted in transit. Implement access controls to restrict access to sensitive data to authorized personnel only. Ensure that robots are running on secure networks with firewalls, intrusion detection, and prevention systems in place. Regularly update software and firmware to address any known security vulnerabilities. Monitor system logs and audit trails to detect any suspicious activity. Use data encryption to protect data at rest, such as on servers or in storage systems. Train personnel on how to handle sensitive data and how to recognize and report security threats. How can you comply with data privacy regulations in robotic process automation? Here are some ways to comply with data privacy regulations in robotic process automation. Identify and classify sensitive data, such as personally identifiable information, PII, and implement appropriate security measures to protect it. Obtain explicit consent from individuals before collecting and processing their data. Implement access controls to ensure that only authorized personnel have access to sensitive data. Anonymize or pseudonymize data to protect individual privacy. Implement data retention policies to ensure that data is not kept longer than necessary. Regularly audit data usage and access to ensure compliance with privacy regulations. Train personnel on privacy regulations and data handling best practices. Thanks for watching. For more information, like, comment, and subscribe our channel.